Oh, there we go. We're rolling.
Got it.
Okay, cool. Thanks, Faith. So yeah, functions are a big deal. We build castles of thought, right, out of code, cathedrals of thought out of code, and functions are a huge building block in that. They're right up there with conditionals and loops and fundamental data types as things you have to know to be able to say you know how to program in a programming language like Python. Does anybody see something different about my print length max min right up here?
The color of the text?
Yeah, I don't have parentheses, and I'm not running the function. So when you type the name of a function without parens, you get the function body, right? So when I type the function max, we see that max is a function, right? And when we ask what type of data type it is a built-in function or method. So Python's not showing us the code underneath the hood that makes max work, but this is the difference between having a spell in your spell book and casting your spell. This is the difference between having a blueprint and building off of that blueprint. So a function's body is its definition. And this is different versus running. So running, calling, executing, or invoking, they all mean the same thing. A function means to tell that function to run. So we can say max 1, 2, 3, 4, 5, and 99. So max only runs when we have parentheses. So this is something that we need to pay attention to, both in custom functions that we build and with the built-in functions in Python, right? There are times and places for using the function's body without the parentheses, but basically we find ourselves with a two-step process when we build our custom functions. We write the function, and then we use it when we need to use it, right? So let's get into user-defined functions. So you can define your own functions, and those 101 exercises had y'all build something like, I don't know, 70-ish, 80 functions. So y'all are not coming in totally fresh to user-defined functions, but in that platform, that 101 exercises platform, the platform told your functions to run for you. So we're going to see something a little bit different when we start writing our own functions. So a little bit earlier, when I was asking for built-in functions, I heard somebody say average. Surprisingly, average is not a built-in function, not even AVG or mean. It's not there, right? So I'm getting a name error because these are neither variables nor are they functions, right? And function, you basically need to have functions and variable names exist in the same space, right? So let's talk about the anatomy of defining your own function. Step 1 is the def keyword. Step 2 is the name of the function. Step 3 is the parameters in the parentheses. And step 4 is the body of the function with a return. Okay, so let's do that. Let's build an average function. So def is our first piece. So we're saying, hey, Python, we're defining a new function and we need to give it a name. We're going to call it average. We'll just say AVG for short. And the average function, it's going to have inputs, right? We don't want this to be hard-coded. We want to get the average of any list of numbers or sequence of numbers, right? So we can say, give a variable name right there, the parameter in the parentheses, and I'm going to put this in quotes in the notes here, the input variable, whatever they are. And we have a nice little colon, and we can return the sum of the numbers divided by the length of the numbers. And this function is going to blow up if I don't send it the right data type, right? So we could do some data type checking. We could say if type of numbers is not a list. So let's do a type of a list here. We can return, I don't know, none. And we can also, we could go into each and every element of this list and double check that it's a number. I'm not quite going to go down that path right now, but what we do is if we have a nice list, we'll sum up the numbers and divide by the list of numbers. So we've defined the function. So function definition, I'll put this in the notes. Function definitions are blueprints. We can think of them of function definitions as spells in your spell book. Just because a spell is in your spell book doesn't mean that it is currently being cast in the universe, right? Same thing with a blueprint. Just because a blueprint exists doesn't mean that somebody has followed those directions to build a house. Okay. And check this out. When we put the body of the function, or the name of the function without any parentheses, we're told that it's a function that's called average, and its input variable is called numbers. Okay. I'm going to add a little piece to the anatomy. This is not required, but it's a very nice to have a docstring. Docstring in triple quotes that communicates what your function does. Okay, so I'm going to show y'all a little something. If we make a happy little docstring here with triple quotes, and I say returns the average of a list of numbers, returns none if the input variable is not a list. And then maybe, so this is kind of interesting. We've got this, it's not a comment, it is really a string. Triple quotes means a string, but when we have a triple quoted string as the first line in a function, it's called a docstring. And here's what a docstring is going to give us. You'll remember on Jupyter, you can put a question mark after a function and you get how to use it, how to use that function. You'll remember that in IPython or Jupyter. Check this out. We can now ask questions about the function we just built. So by building a docstring, you're building out documentation for your code. And like commenting your code is pretty important, but this IPython doesn't read comments for you, and comments aren't meant to be read. I'm sorry, comments are meant to be read by human beings. Comments are not read or executed by Python. But a docstring, we can get in there. So this is how we start producing documentation about our functions, which is really cool. The super cool part is we can now, anytime I need to average some list of numbers, I don't have to do sum over length. I can call this function and set it that input. So if we have some input like A, 3, 4, whatever, and then we call our function, average of A. Oh, let's see, I've made a problem for myself. What am I doing here? I have a feeling this is returning none, and it shouldn't. Yeah, it's returning none. Maybe I goofed up my conditional here. So I'm going to print out the type of numbers here, and then run the function again. Aha. So class list. I'm just going to pull out this data type confirmation stuff for now. It's a moving.
Is it because your not equals was inside your parentheses?
No. Oh, maybe that is actually. Yeah. Forgive me. Somebody on the welcome call to Oberon said I knew Java, and so that meant it flipped me into frickin' Java mode today. Sorry about that. Yeah, but let's try that out. Not equal to list, return none. There we go. Cool. So we can keep it. I had a syntax error. You don't need parens around your conditionals in Python. But let's see, we can pull that debugging because I don't need my debug code hanging out in every function. I want my functions to be reproducible, like machines, like a little butler or a little robot that always gives me the average. And we get exactly that. Okay. So now I never have to figure out how to determine the average of something ever again. All I got to do is make sure that I have this function built out. So in this way, what we're doing, building out our own functions, allows us to name procedures, sequences of steps. And thank you, Ray, by the way, for the debugging of steps, and give them a name, right? Naming a sequence of steps. Once you have a name for a verb or verb phrase, it's kind of what functions do. Functions are verbs, right? Really, they're a process, they're a procedure, they're a verb. So once we have a name for a verb or verb phrase, we don't have to even think about or worry about the internals. So this allows us to do some fairly complex stuff, right? When we get into our machine learning later in the course, we will be sharing how to think about the math going on, but you don't need to like write all the math that performs a linear regression. You call a function that does all the math for you, right? Same thing with our hypothesis tests and statistics. You need to know what's going on, but you don't need to write all of the code. We're relying there on other people's function definitions. And so as you're building your own stuff, you can build more and more and more functions. And start building up libraries. And we'll talk about libraries tomorrow, but as a preview, we can make libraries of our own functions. We can use other people's functions. We can use built-in functions to Python that we hadn't even seen before. Okay. Questions so far? I'm gonna pause real quick and give you all an opportunity to ask any clarifying questions around these topics.
I have one. Oh, go ahead, Natasha.
So once you've defined this function that you created, how long does it last? Is it just in this sheet or until you close out of there, or how?
Yeah. What I'm hearing in your question, Natasha, is the vocabulary word is called scope. That's the name of like how long something is available and where it's available, more importantly, and where average is available is anywhere else in the rest of our notebook.
Okay.
Yeah.
Perfect. Thank you.
Yeah. So when you define a function at the top of a Python script, you can then use that function beneath it.
Okay. Perfect.
The rest of that script. Yeah. Yeah. Good question. Good question. Next question. Go ahead.
So if I thought that average was a built-in function in Python. Am I wrong?
Yes.
Oh, okay. All right. Yeah,
it's a reasonable expectation because Python has so many built-in functions. I'm actually rather surprised it doesn't. But
yeah, because my question was going to be, okay, if it's a built-in function, why do we have to define the return as an average? But since it's, I guess,
doesn't exist.
Question, yeah. Thank you.
Mm-hmm. We in our data science libraries that we'll get to later, averages built in all over the place. Yeah. Cool. Go ahead.
So like, if it doesn't have averages built in, does that mean it doesn't have things like standard deviation built in as well?
Yeah, yeah. Let's talk about that. Like, what would we call it if we do standard deviation? Does that exist in the memory? No. If we do STD DEV, it doesn't exist in memory. So this is why we're going to be dealing with lots and lots of libraries of functions, and we're going to introduce that tomorrow. But it's entirely possible to find libraries with, and we're going to be using them the rest of the course, that have standard deviation. I'll give you an example. If we were to import pandas and then make a pandas series out of a list, we could get the standard deviation. Import pandas as PD. So just reaching ahead a little bit here. Rather than taking my word for it that we will import things, folks, y'all are basically going to use so much pandas the rest of the course after we get there that you'll start to forget basic Python. It's so powerful. But I digress. That's a little outside of scope for right now. Did that answer your question, Forrest?
Yeah, I also get why like you understand libraries now. You're basically just like importing functions that
that's all it is. Yeah. And we'll do the nitty gritty with imports, like the details on how to make your own modules to import, how to import other people's code. We'll get into that tomorrow. But yeah, if this is really kind of a magical thing. If you don't have something as part of the language, you can build it, right? So we could say, if we had a problem that's like, write a function called second smallest that takes in a list of numbers and returns the second smallest number. So what I want to do here is give y'all a little trick. So this is our exercise here that we'll do, and we'll build that up together. And I'm going to give y'all one weird trick. It's just like that looping thing. So one weird trick to authoring a function. What do y'all think the one weird trick is going to be? Anybody have a guess?
Blow off.
What up?
What are we going to blow off? Blow off the function. Now that sounds crazy, but we saw on Friday that the best way to make code to solve looping problems is to blow off the loop. I'll make the same assertion. Let's say we have, so blow off the function, which is to say, build out the code that the function should do first. And then we can bring the function back in. And we can wrap that code in a function definition. I'll give you a little trick. It might be outside of, yeah, it's a little off topic, but I want to give you all a keyboard shortcut. Do y'all see that I'm skipping around with my cursor based on words here? The keyboard shortcut for that is Option, and then a left or a right arrow. Option, left or right. And that also works on pieces, that works everywhere, not just Jupyter. It works everywhere on a Mac that is a text input. And you can move to different pieces of a URL, for example, or navigate around. Anyway, I wanted to show you all that. So if we need to get the second lowest or second smallest number in a list, we should sort the list, right? And then I might say we should remove duplicates because the second smallest number of 1, 1, 2 is 2 and not 1, right? We should rip the duplicates out. And I guarantee you there's not a second smallest function just hanging out in Python already. So, and then return the second item of that list. Okay, so let's say we have some list of numbers, 1, 1. So 1, 2, 3, 4, 4, 4, 4, 5. Okay, we get this, we make a little list right here. And then I'm going to put this in order. So I'll sort that list and then we'll print it out. Notice I've got that function in mind, but I'm not fussing over it just yet. I'm just getting the internals working first. Okay, so I've got a list of numbers, they're in order. And now if I want to remove duplicates, it's a pretty cool trick. We can use set. So sets are a data type. We haven't really talked about them yet as far as a lesson goes, but sets are mathematical sets. And actually, I'm thinking we might even do the sorting after we do a set, because sets do not guarantee order, but they remove duplicates. So actually, I'm thinking I might move that sort a little further down. So if we make a set out of our numbers, we then have only the unique values, which is nice. But see how the data type changed, right? So I'll want to set that back to a list, numbers, and then we can put things in order. Again, there's no guarantee of order for a set. So we'll put things in order and then check our numbers, okay? And how do we get the second item? It's bracket 1, gives us the number 2. Okay. I'm not expecting any dissertations on sets just yet. Don't worry about it too much, but now we have this, this kind of little procedural code that works on this hard-coded list. So now we can go to, we can bring back or wrap this in a function and a function definition. And instead of a hard-coded input variable, we create something called a parameter. And a parameter is a fancy name for an input variable to a function. So we copy the guts. We define our function, second smallest. And look at that, I already know what I'm going to call my input variable because it's what I was using earlier, numbers. And then I'm going to tab all this stuff in. And I'm going to return this. So something that we always need to do is return values from functions. I mean, not always, but basically always. Until you know what you're doing, return, 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 return. So now we can call second smallest on any list. Give it. Right, if we send in a list of numbers that only has one number, we'll get an index error. We could probably protect ourselves from this index error by double checking the number of items on the list, right? But it just keeps working. And now all of this thinking that I had to do to figure out, how do I figure out how to use a set? How do I figure out how to sort the list? How do I get the second element of a list? All of these sequences of steps you can now let out of your head and rely on the name of our spell. Follow the, and in fact, we're telling Python, hey Python, follow the blueprint, but with a different input. So I need to be very explicit. What's going on here, when we run second smallest and see how we're sending in this input list starting with negative 111. What's going on when we call a function is the input will be stored as a variable inside of the function as the parameter name. So this parameter name is very, very important. This is how we're sending data into the function, right? And because we can't just change the source code in the middle of the program running, right? We need this function to be able to run on any input of, right? Any input at all. So when we send in the list 345 and on cell number 50, 345 is what's held behind the variable. We take the set of the numbers 345. There's no duplicate, so it's just 345. We turn it back into a list. We sort our list. And then 345, and we return 4. It's also entirely possible to have multiple input arguments. For example, I'm not sure if that's how you spell hypotenuse. Hypotenuse. Okay, hypotenuse. So to calculate the hypotenuse's length, and we're going to assume this is a right triangle, so like that whole Pythagoras stuff can work. All right, so let's add a little doc string, and we'll say returns a squared square root of a squared plus b squared. And I'm going to put right here in my doc string assumes this is for a right triangle, because the Pythagorean theorem doesn't work out on other triangles. So okay, so we can. This will be a pretty simple one-liner, because a squared is a squared. And then we can do b squared. And then this whole expression will take the square root of. There's a couple of ways of getting the square root. Raising something to the half power. Raising an expression to the half power returns a root. But a little more easily, we can import math. Why not? I know I'm getting a little ahead with an import, but that's cool. Math is pretty important. So we can do math dot square root on there. And now I don't have to consult how the algorithm to determine the length of a hypotenuse. From now on, I can call it and say length of 3 and 5, and then our hypotenuse will be 5.8. And again, if we're in a Jupyter Notebook or IPython, you can type the name of a function followed by a question mark, enter, and you get how to use the function. So if you're writing your own functions and if you don't have a doc string, you write your own function, we don't have any information on how to use it. Right? So I would say, notice the doc string right here is no doc string, like it's judging you or something. So let's avoid that judgment. Add in a doc string, returns the square root of a squared plus b squared. Assumes this is right triangle. Okay. So notice this. Notice a couple of things. I want you to pay attention to the fact that we are using multiple inputs here. And I imported math to make things work. So because I imported math in cell number 58, I could use math outside. Right? But can I get at A or B here? The B variable, right? This B is some other B that existed farther up here somewhere. 43 has nothing to do with either of those two inputs, just like A was an input earlier in the script holding onto a list. So something that's very important that I want everybody to pay attention to and really get a handle on is when we define a function and provide the parameters. Parameters is a fancy name for a function's input variables. When we define a function, there's something called the function scope. And what it means is any variable that's coming into the function, or that maybe we make a variable called result inside of the function, and then we return the result. We do this all the time because this may be a more complicated affair, right? Result is not accessible from anywhere else in the script because result, its scope only existed inside of the function definition. So this is a new topic. We really haven't had to talk about scope much already, because if you define a variable at the top of a script, you can use it at the bottom of a script, right? But think of scope as like a little bubble, right? A little bubble of where code is visible and reachable by other pieces of code. Right? So some places where we might we might find scope in work you've already done is we could say, I want to say if, we'll do an if false here. So coffee is light roast. Right, check this out. If I try to, because this if doesn't run, that assignment never runs. If else's and while loops also create their own scope. So if we never ran this line of code, we don't see that coffee there. Okay.
But if you define that variable outside of the actual definition, the definition of the function, like just one indent to the left, then that will be a different story, right? That will amplify the scope.
Yes, yes, very true, very true. So if we say coffee is none yet, like maybe we haven't made any coffee yet. In the scheme of this conditional, it's still not yet. If we change the conditional here, so that executes, then that line executes, right? So think about functions as, let's see, maybe a function diagram. Let's see if we can't find a nice little function diagram here. I like to think of functions like a little machine, almost like a juicer. Perfect, here you go. Here's something probably from a math class or something like that. Uh-oh, there we go. Okay, cool. I'm so confused by this Pinterest platform. Wow, go away. Go away. Okay, there we go, much better. I just needed the image. Think about a function as a machine. And in your mind's eye, I invite you to think about a function like a juicer machine. There's some sort of input, you put in carrots, your output, your rule will be to make juice out of whatever you put in. So your output will be carrot juice. If you put in beets, if your rule is grind everything up and separate the pulp from the juice and return the juice, and then you've got beet juice, right? So looking at what we're doing here, we're defining our own processes. So whatever the process is, and I need to tell you now, always return values from your functions. Like it's critical, and I'll explain why. What if I were to say def? I know this function already exists. We have an uppercase function. We'll take in some string. And what if we do string.upper? We call uppercase on banana. Notice we got nothing here, literally nothing. If we can set this to a variable and ask the type of that variable, it's none. So this is a cautionary tale, folks. If you don't have a return, your function automatically returns none. And none is not how you build a cascade of chain reactions and a cathedral of thought and a castle of thoughts and procedures, right? It's always return things. So it's a none type, right? So if we have a return, then we're actually getting output. It's a pretty big lesson, and I need this to sink in as soon as possible. Here's another failure case. So So here's a cautionary tale, always have a return. And I'm going to give y'all another cautionary tale. Let's make a avoid print like the plague in functions, unless you're purposefully printing to the screen. Actually, just avoid functions like the plague and print the result, print the result the function returns instead. Here's my example. Let's say we make a lowercase function, takes in some string, and what if we were to do print string.lower? Now the code's going to do exactly what we told it to do, right? If I try to lowercase the string coffee, right? We print out coffee, but what if I had an input here called x? Notice that the data type of x is none. Why is the data type none?
The variable is never actually set.
X is set. Let me go one more layer. Why is the variable the variable is set? It's set to none. Why would the result of this function hold none?
Because you never assigned the lower coffee.
Yeah, X is whatever you return it to be, and if you don't return anything,
Yeah, you're just printing it, so it doesn't store the return result.
There's no return.
Yeah.
How can we return a value if we don't return, right? So here's another failure case. What if you return print? The print still happens, but we still get a none type. This is why print's the devil inside of functions. It's good for debugging things, but it's bad for building a chain reaction. Heather, do you have a question?
Yeah, I learned the other day from Madeline that print returns nothing.
Yeah, print returns nothing, actually. If we print out something, print's return value is none. So it has a direct effect, but because print returns none, if we return something that returns none, that's the same thing as returning none. So return none is returning. Yeah, avoid print like the plague inside of functions. And I'll give you the way to kind of solve for this just a sec. So if we were to do print string.lower, print stuff, but doesn't return anything. I'll ask it that I'm going to hammer this point home just a little bit more. Let's say we make a function called tax return, and you put in your tax stuff, right? Whatever your tax stuff is. And in your tax return, I have a question for you. Let's just say this. The amount is, I don't know, let's say $500 or something like that. Do you want a tax print? Or do you want a tax return?
A
Imagine,
tax return.
yeah, imagine trying to cash a check that doesn't have any values behind it. That's a non-type. Imagine hitting an ATM and the ATM screen prints that it just gave you money, but the money dispenser didn't give you any money. So printing is not the same thing as returning a value. And that's pretty important. I don't want to hammer that home. It sounds like you'll have this.
So in order, when you're, so I guess if you're making a function and you want to kind of check it, if you put both of those things, print and return, then you can, eventually get rid of your print statement, but like leave the return or test it outside of your function and run it later, see, what's going on.
But yeah, I'll recommend printing the result of the function call. A function call is what the expression of running the function means. We can totally print inside of functions, like we just saw that we could do it. My advice is print variables if you're like doing some sort of debugging of your function. I did that a little bit earlier, right? Print your variables if you're debugging. But once we are done debugging, we don't want to print, because like it would be really weird if somebody's running your code and there's a bunch of debug prints going out everywhere. That'd be like if you visited a web page and there were a bunch of printouts everywhere that said, "This is working now," something like that. Right, Emmanuel, question.
Yes, in this case, in line 89, wouldn't you like to, what would be the difference on returning the amount and returning tax return? Because the function itself is tax return, right? And amount is just one element within that function, correct?
Yeah, the difference between amount and tax return is amount is a variable, tax return is the function's name. And we can't, you don't want to return a function's name unless you're doing something called recursion, which you probably don't want to do by accident. Did that answer your question, Emmanuel? Or did it make another question, or?
No, perfect, thank you. I can look more on the recursion thing, but as long as I just wanted to make sure that I sorted those two out. Thank you.
Yeah, recursion is when a function returns itself, which is a kind of it's very similar to looping. Song that never ends. Oh, this is fine. It's just a song. I'm going to print out. This is a song that and on my friends. So if we have a function that returns a function call to itself, then ladies and gentlemen, folks of all kinds, we've got a song that never ends. And this is going to blow up my notebook. Because what happens? Code does what you tell it to do. We told it to print 3 things. Then we told it to return a call to the song that never ends. And now this has run thousands and thousands of times. It might crash the notebook. So I'm going to hit the stop button here and stop this cell from running. Oh, look, my notebook's non-responsive. So recursion without some way out of the recursion is very similar to an infinite loop. I hope this helped to make a point.
I was wondering, I was just thinking, I had a thought, and I don't know if this works, but can you stop a function like that with like a like a global variable or something like that.
Yeah, we could have like a counter or something like that.
But
Or-
it wouldn't, probably would have to, I mean, if it was, you know, maybe counting how many times it did it, it'd have to count maybe somewhere outside of that one. Or I guess you could count inside as well.
Mhm. True story. Yeah. There are programming languages on the planet that prefer recursion to loops, but basically we're just going to prefer loops in the class here. There are things in the planet that are recursive in nature. I would argue that a bar tab is recursive in nature, right? Every time you order something at a cafeteria or a bar or something like that, you make a new order, your new total is in terms of what the old total used to be, plus something. That's a recursive data structure. What did you learn at Codeup today? That a bar tab is a recursive data structure. Wow. Anyway, let's see. I want to make sure it's about 10 o'clock. I know that there are some topics I haven't yet covered in the lesson. So I want to give you all a chance to ask any clarifying questions right now. We don't need to chase a recursion rabbit, the recursion rabbit in the recursion hole. But I want to take any questions right now, and then we can take a short break and come back with more pieces of functions. Open forum if you have questions right now.
I have a quick question, Ryan.
Yeah.
So for example, you defined hypotenuse like earlier. Can you write like write a function within a function? Like if I need to use hypotenuse to find if I want to write a new function to find like an angle of a triangle and I need like the hypotenuse that I already defined, can I do something like that or?
Yes. Yes. Absolutely. So we can say, we can call another function within inside of another function's definition. And that's literally how we make chain reactions, right? To transform data. So I'll give you an example. I'm going to make a happy little function here called remove the $sign. So it takes in some string. And if there's a $sign in there where we're going to return that string, let's see, let me follow my own advice here. How to build a function. Blow off the function first. And make a solution that works on a single input. Okay, so we can say, remove a $sign from the string. So if I have some string that's like $sign, 2, 3, 4, we could do x dot replace, or x is x dot replace. Maybe not x, but string is a little more meaningful. String, not stir, because stir is part of the program, part of the Python language. We'll replace the $sign with nothing, with empty string. Okay. And then, so this is looking good. So to turn this into a function, I'm going to have, I type, y'all talk. How do I turn this into a function?
Write the DEF. That's a first step. Then they'll call your function's name. Open parentheses. And inside the parentheses, you are going, well, actually, that's going to be empty. Then a colon. I'll stop there.
Yeah, let's talk about this emptiness thing. If I don't provide a variable input right here, this function will only run on this hard-coded example of the string $1,000, 234. So we want to make our function reusable. So instead of having this hard-coded bit, we then make sure that that's the input variable. That's a very important part. Did y'all catch that?
Yeah.
Because the purpose of a function is to be reusable on many different inputs, not just a hard-coded thing. Like this tax return was an example. It totally hard-coded the amount. It didn't take in any inputs because I just wanted to simplify, right? So what we'll do here is We've got remove $sign on a string. The colon works just like the colons on ifs or while loops. It's saying anything that's indented is the body of the function, is the sequence of steps that the function does when we tell it to run. And I'm almost done. What's my next piece here?
Return.
Return.
String.
The string, yeah. Bingo. And we can test this out by running this with 1, 2, 3, 4. It would help if I put a string inside of a string, right? Right, so I'm gonna build up another function, remove commas on that string. We'll do string is string.replace the comma with empty string, and then we'll return that string. And now I can put these all together. We can say clean price or clean money. Ooh, launder money, there we go. It's a Breaking Bad episode. And what we can do here is say the string is now, let's remove the $sign from that string and reassign it. Then let's remove the commas of that string. And then we'll return the string. And so this is in answering Desiree's question, can we have a function call inside of a function definition? All day long, all day long. We're gonna do a lot of this. So now we can clean our money. And if we have a $sign and 2, 3, 4, 5, we're good. We're good there. And I might go a little bit further and make sure to add another little piece of functionality and get rid of the strings, turn this into a float. Yeah. And this is how we can make chain reactions. Literally, this clean money function is a chain reaction. First, we remove the $sign, then we remove the commas. And you may see, if we remove the $sign and then we remove the commas, you may see something that looks like this. Remove commas. This is doing the exact same work. So first, remove the $sign, then remove the comma. See how we're using the output of one function as the input to another function? We're doing that in a one-liner in cell number 10 here, right? But we did the same exact sequence of steps in cell number 8. We did one thing and then the other. And so we can, y'all don't have to write all of your codes such that you have function calls going into function calls, but I need to make sure that y'all know that this is possible. And this is why return values are so dang important. If I was printing stuff or had a none here, I couldn't keep operating on something. But if we return a data type, we can keep working on that data type. Just like we can take the string coffee and we can uppercase it. That gives us a string, right? We can then lowercase the string, and then we can uppercase the string again, then we can lowercase the string. Yep. See what I mean? We can make chain reactions. The syntax for these string methods are different. Methods are functions that live on an object. And methods are called with a dot notation and then the function name. Cool. All right. Questions about this demo? I wanted to answer Desiree's question. It was a really good one about, can we talk to another function from inside of one of our function definitions? And definitely is the answer. All right. No questions right now. That's a-okay. Let's take a little break. How does 15 minutes sound this morning? Let's do it. 10:30, I will see y'all at 10:30 and we will talk more functions. Yeah, so a lambda function is mathematically, all it is a function, right? Anywhere in mathematical literature, if you see lambda calculus or anything, or anybody talking about a lambda, unless that's a variable used for something specific, they're talking about functions. In Python, we have syntax for making a lambda function in a one-liner. So there are sometimes times when we want to have a function defined that's really, really short, but we just want to define it all in one line. So I'll actually share my screen and we'll start getting into some of these other topics that are in the curriculum that I hadn't yet covered with my notebook, and lambdas are one of them. So if we were to ask what our data type is of clean money, that's a function, right? And if we were to ask the data type of remove commas, same deal. It's a function. And lambdas are just functions. So let's build so a lambda is technically lambdas are anonymous functions. So it's a function without a name. And I'll pull up, I'll have my code on the right and my reference on the left. And these are the last little bit of the curriculum here. So we'll start here. So if we say lambda n is the parameter, lambda is just another way of saying function. Something that is nice about a lambda, lambdas have an automatic return. Lambdas are one-liners, and lambdas are just functions, so don't freak out. So lambda n, and then we can do n plus 1. That's a function, right? And if we ask the data type of this function, hey, look, it's just a function. So it's an alternative syntax. Lambdas functions are an alternative syntax that allow us to have an anonymous function. Anonymous functions, initially, they're not terribly valuable because we don't have a name to call this thing. But here's something that we can do. We can assign a lambda to a variable, thus creating a function out of that variable. So we can ask the type of increment, see how increment is a function. So now I can do increment 1, and it does that very thing. Notice with a lambda, I didn't have to write a return, it's implicit. But lambdas are one-liners, and I invite you to build your castles out of things that aren't one-liners. That's just an invitation, that's a recommendation. But lambdas can be very useful if we need an anonymous function in the middle of something. It'll be a little while before we introduce lambdas in concert with other items.
Okay, so I was just kind of, when I was reading through it, I was wondering like what you would use it for. And it sounds like you'd use it for something like not too crazy because you kind of want to fit it all in one line. And so if you really want to start doing some really crazy stuff, you should probably just define your own function, like, and give it a name and build your castle, as it were, and not try to do it all in one line. So this would be something simple that you probably want to try to do in here.
Do an example of a lambda function in Python with a list of dictionaries. Here's really where we'll find a value in a lambda. Here's a good example. We'll get some list of people. Hey, look, it's a list of dictionaries. I keep suggesting that it's this important thing that you're going to see over and over and over, and it's true, it is. So say that we wanted to sort these people by their ages. So let's change the ages a little bit. There we go. So if we want to sort this, list of dictionaries, we could sort our list of people, sorted rather, people, and notice how the key argument here is going to be a lambda. Lambda P for person, colon, and then we'll sort by PH. We can use this also. See how I'm using the lambda in concert with another function? This is really the use case. So say we want to get the max out of the people, lambda person H. So get us the highest H out of there. Same thing with men. So in some places, we can use lambdas as part of a one-line solution. You don't have to, like, this isn't, lambdas aren't going to be on the assessment. You can live a very happy data science life, relying very heavily on just regular old functions. But it's important to know, because once you see a lambda, you need to know how to unpack it and use that. Okay, so if I were to make a function called increment that takes in some number and returns x plus 1, that's the same thing as saying, I'll say increment 1, and then I'll make another function over here called, or a lambda over here called increment 2. Takes in increment 2 is some lambda, takes in x and returns x plus 1. See how the guts are the same here? You're taking a variable, adding 1 to it. That's it. Heather, did that answer your question about lambdas?
Yes, especially the side by side, just to kind of compare what goes where if you're doing something differently. That's very
like really the second that you have more than one line in your function, the lambda is the worst tool in the world to use. Worst, absolute worst. Or if you have 2 inputs, I'd recommend not fussing with a lambda. Yeah, Lynn, go ahead.
Yes, so I have a question. I'm just looking where you said where you put sorted people key equals lambda.
Mhm.
When is that just changing the, like, creating another key? Is that what that's doing? The key equals, or?
Yeah, the key argument on min, max, sorted is saying I want to sort by a key in a dictionary.
Oh, okay.
Because like we can't just take a dictionary like the regular if we just do sort on a list of numbers, right? I need a comment in there. I was typing too fast. Ugly commas because I was typing too fast. There we go. All right. So sort works just fine on numbers, but how do you even start sorting a list of dictionaries? What if we wanted to sort that list of people? It doesn't even know, or sorted rather. Because the sorted function is using the comparison operator greater than or less than by default, right? Less than by default. So it's putting them in an order. What if we wanted to sort our people not by age, but maybe alphabetically by their name?
That makes sense. Thank you.
Yeah. And this usage right here is where you're going to see most of your lambdas. Like 90% of your lambda usage. Cool.
I was working on the extra credit that we had for the 20 problems, and is this the best way to navigate through what's the word? Navigate through list of
list of dictionaries?
Yes, that's the word. A list of dictionaries.
Yeah. Well, I don't know if I'll say this is the best way, but max, min, and sorted, they allow us to use this key here.
Okay. Yeah, because I was solving them using this method. I just wasn't sure if there was a better way, because my first instinct was to extract just what I needed and put it into a list, and then to kind of use a key value
Mhm.
to find the value at that key. That was my first instinct, but then I was like, I did some research and I saw this and I was like, okay, this seems like it might be better.
Yep. Just a different way, just a different path, right? And this is a good example because these are nice little short one-liners where it would be possibly more work to do def, sort by age, parens, x, colon, return, whatever. Yep. Cool. Let's keep on going. These are great questions. So we talked about lambdas just now, and as if you assign a lambda to a variable, it's literally the same thing. Notice right here, comparing increment 1 and increment 2. If we were to ask the type of increment 1 and the type of increment 2, they're identical. They're both functions. This isn't some wacky new thing. It's just a different way of making a function. Okay. All right, so let's keep on going. Let's talk about vocabulary. I've been using this term parameter when we define a function, and we have the parameter in the parentheses. Parameter is the name of the placeholder variable for the input. And then when we send in, when we call that function increment, and we send it an input, the input on the outside of the function definition is called an argument. Not because we're angry or in disagreement, but because this is a specific name for the input variable coming in, right? So if we were to increment, 3 was the argument to the first call of increment. And this is just like math with the parentheses. You work from the inside out with the parentheses, just like math. You increment 3, which is 4, and then we increment 4. Okay. It is entirely possible to build default values in functions such that if you don't supply an argument in the input, that there will be a fallback. So we can say, make maybe a greeting or something like that. So with this greeting, maybe we have greeting variable and a person or subject or something like that. So we can return greeting concatenated with a space, a comma space rather, and then the name concatenated with an exclamation mark. And then we can say hello to everybody. We've got a nice little hello world there. But if I tried to run this function with no inputs, I get a type error. It's like, oh my gosh, you told me, you gave me a contract when you defined me. My contract says that I am going to get 2 inputs. Think of function inputs and outputs as a contract, right? You're specifying things. So if we wanted a contract that was a little more flexible and had some default values, here's what we can do. We can say that the greeting will default to hello and that the name will default to world. And I'll redefine this. So if we send in arguments, our own arguments, everybody takes over here and say hello with nothing says hello world. And if we're feeling very, very, very morose, we could say, set the greeting to goodbye. And if I leave off an argument of the world, the default will take over, and this is goodbye world. Right?
So in that case, if you do have some default, so when you're saying, I guess, greeting equals goodbye, are you, could you just say hello, goodbye, and just type in goodbye and then not have a second argument, or will it give you?
True, I could. In this case, the order of operations will be left to right. But what if I wanted to say hello to just Zach, right?
Then it'll say Zach world.
Zach world, which is a pretty cool place to be. But I say that because Zach Gouldy on the data science team has been on loan to web development for a couple of months, and he's rejoining us this week, which I'm very happy about.
So if there is so if you have two different arguments, you need to, if you're not inputting all of them in order, you need to specify which one you're doing.
Yes, we're specifying the keyword argument.
So let's say like your function needs like I know that some functions take in like different, like if you want to do, I don't know, I think it's like the length function. Some functions take like stuff and then you have to put like a semicolon or like sorry, a regular colon, like a number and then another number and then another number, but the other two numbers are usually optional, and I don't know, it outputs like, I'm thinking like mostly like formatting stuff. If you want to format like a decimal point or something like that, it takes a couple of extra arguments. So in this case, you always have to say something equals whatever. If you want to define something that's not the first one, I guess.
Yes.
I guess that's it.
Yes.
Okay.
Yeah. So if we do things in order, we could do 5, 6, 7, and then we could read from the left to the right, which is kind of implicit. That doesn't have a lot of control, right? But if we say add stuff and we only want to reassign C to some number, right? It'll take that C number and add A, the default for A, the default for B. Because what's going on in here is variable assignment if there's not already. Basically, there's a little conditional in the Python code. It says if there's nothing sent in, assign that variable to be 1 or assign that variable to be 2.
And can you have like different data types in your argument?
Mm-hmm.
And I guess is it probably good practice to put, if you have something kind of complicated that's not really intuitive, to put like something in your docs saying like, okay, these are all the variables and you got to put them in this order, otherwise it doesn't work.
That's what doc strings are for. So doc string here returns a given string repeated a specific number of times, and then we'll say default arguments are, I'll just copy and paste this right here so we know. So if you don't send anything in, right, and then we can say return string times the repeat. So when we repeat the string with no inputs, hello, hello, hello. When we repeat the string, the relying on left to right order, we could say cool times 5, right? Cool, 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 cool. Or we can say repeat the string. If I don't specify the arguments, but I just rely on the first one, I could say all right. And it defaulted to 3 times. So all right, all right, all right.
Does it make any difference because they're different types? Do you still have to specify in the order? Like, could you just say repeat string 5 and it should know to find the integer, or no?
No, it's left to right, and which is why we call these keywords. Okay. So if I say repeat string and I say 5, check this out. We're gonna get 15.
Okay.
Yeah. So if I wanted to repeat the string and set the number of repeats to 5, we'll say, or maybe 2, just hello, hello. Yeah. Did that help with the default arguments here? And we see this all the time. I think y'all are getting the gist of default arguments here. What if we were to look at something like sklearn? Look at a machine learning model. Why the heck not? Show you what's in your future. Let's look at the documentation for a decision tree classifier. It's a machine learning classification algorithm. Decision trees are it's a binary decision tree, so it's like asking your data set 20 questions to get to the heart of the matter. And what we see here is that there's all kinds of defaults, the criterion, the splitter, the max depth, the minimum number of samples. I'm not going to go into what all these things are, they're out of scope, but we see that there's a big honking list of defaults here. And when we use a decision tree classifier, we in some places will rely on the defaults, and other places we need to make sure to overwrite them so that the code does what we need it to do. Okay. So this is what your future will look like, is figuring out, okay, if I use all the defaults, maybe you make a decision tree with all the defaults. Then you make a decision tree with different arguments to see how well that performs. Okay. Great questions, y'all. Very great questions. So default values come up all the time, and we need to not be afraid of them. We're not afraid of them, but just we need to know how to use them, and that if you don't provide the keywords, then you're going to have a bad time. And because the keywords are like assigning variables, we can put them in different orders, right? We can say that our string here is ahoy. See how the function is, if I specify the keywords by their exact variable names, I don't have to remember if the string was first or the repeat argument was first.
Could I put something like another variable as 2? So for example, if I was like somewhere else in my program, I was getting a counter or something like that, or I declared a global variable to be, I don't know, some number that the user inputted, could I put the repeat set to that variable? In that case, I'd have to say like repeat equals, and then whatever the name of my variable is.
As long as that variable is set by the time your function definition runs, that can work. If it's not set, you get an undefined variable error as soon as the function definition runs. So if I define some function called stuff, we'll say repeat string repeat equals n repeats, and then this would be a problem because n repeats doesn't exist in the scope yet. So
yeah, so like if you were doing a function, maybe like with not a function, a code that had like, okay, you got some input from the user, so your function n repeats was n repeats equals input of whatever the user was gonna put in, and then you could run that function and it would take some input from the user in that case.
If you're doing user input and then the function definition will be defined after you get that input and validate it. Yeah, exactly, totally.
So should you, if you're creating a bunch of functions for your code, just like I know you said that you have to put your up at the top, like if you're importing anything from another library, which I know we're going to talk about tomorrow, but should you define all your functions up at the top? If you get a little bit too crazy, should you put them in a separate thing? Like,
yeah, put them at the top, and then for now, and then as we grow the number of functions that we need to use, we'll create modules that we can import in multiple places.
Okay, cool.
Yeah, great question. Let's see, keyword arguments. We just talked about keyword arguments, right? This example right here. And I'll introduce the concept of star args and star quargs. Really, if we have a list of values that we want to use as inputs, we could use this calling the function with star args. We'll send those in and unpack them in the right order. So I'll give you an example of that. If we said, let's see, yeah, repeat string is our function here, right? So repeat, or we have some variable called x that's cool, and we wanted to repeat 4 times, then we call repeat string star x. See how it's unpacking that for us. But if we have the order of this jacked up, like the number first and then the string, we're gonna, oh, that's wonderful. I didn't know off the top of my head that args would fix it for us. That's wonderful. That's kind of cool. Learn something new every day. We have the opportunity, if we have a dictionary of key values, we can set with ** in front of that variable as the argument coming in inside of the argument variable. If we have keys that match the arguments, then we can use a dictionary as our input. So I'll give you an example. I'll just copy this right here. And so repeat and string are my keys. So I could say repeat would be, I don't know, 5. And then the string itself would be the key. And then when we call the function repeat string with ** in front of our keyword args as a dictionary, it unpacks everything.
Can you use the functionality to just kind of pull all the values from a dictionary if you aren't calling it in a function that you created? Can you just like pull them all out that way?
No. If you need all the keys from a dictionary, you do the dictionary.keys.
And what about the values? You just do the dictionary.values?
Bingo.
Okay, I was wondering if you could shorthand it with the 2 little stars, but
No, what it's doing is the ** is peeling apart that dictionary and doing the variable assignment. And so if I have keys that are different than the variable, than the definition of the parameter, then it's going to fall apart. Like if this was another thing, that falls apart. Yeah, it plays matchy-matchy and matches up the inputs for us. Which is another reason to think about dictionaries as all of the dictionary key value pairs as their own little variables almost, right? Cool. Let's see, function scope and lambda functions. Hey, cool. I talked about lambda functions already. Let's talk about scope just a little bit. More on scope. So I talked about scope as in a function defines its own scope. It's its own bubble. It's its own little universe, kind of like little Russian dolls, little nested Russian dolls. Like each one of those dolls, the outer scope can't see the inner, but the good news is the inner scope can see the outer. So I'll give you an example. My favorite programming language. It changes every week, but this week it's Python. And then we can say def language or something like that. And we can say return. And I'm missing a quote. What am I missing here? Oh, I don't need a paren. Return. Oh, I need to concatenate those 2 strings. Here we go. So see how the inside of a function can see variables on the outside. And we might say language output and then return language output. Let's run that again. If I try to access the language output, that inner variable, I have no ability to see inside of the scope, but the inside of the function can see variables outside. Okay. Generally, I encourage us all to build functions that take in inputs, perform some process, and then return the output so that you have what's called a pure function. It's only dependent on its inputs and only produces its outputs. So A pure function would be something like a math function. Function. So basically, any math function like add, subtract, multiply, divide, right? Any of those would be a pure function. An example of an impure function would be a random number generator, right? You get random, unpredictable stuff back every time. So that would be an unpure function. Also, this language output would be an impure function, right? Cool. So this whole idea of scope, where the local variables are only accessible inside of the function, this allows us to use variables like result over and over and over, or output over and over and over in different functions, and there's no collision at all. Happens all the time, right? This is why scope exists. So scope is pretty important. So let's see, let's recap. Using functions, we've got built-in functions that y'all are already using, rocking and rolling. Defining our own functions is made up of the keyword def, name of the function, parentheses that hold our parameters. Again, parameter, we are assigning the variable a value when we call the function, when we run the function, right? And for now, I would say return values instead of printing until somebody pays you not to, which would be I don't know. Print is not for the inside of functions unless you're debugging, right? Since functions return things, we could have a function calling a function calling a function, and this is a chain reaction, right? And I gave you all a really great example of that, and this is going to come up. This will come up a lot in our data cleaning, where we have one function that cleans one part of the data, another function that cleans another part of the data, and then when we put them together, we are operating on another function's output, making a chain reaction, right? It's like a string of dominoes, a series of dominoes. Because of the syntax of calling functions, the order of operations will be identical to mathematical operations. Parentheses always evaluate from the inside out, just like math. Same thing with the function parentheses here. Arguments are what it's called when we run a function and send in an input. A parameter are the variables that hold that input. So when we look at this add function, A and B don't have any values until they are assigned values by the function invocation, by the function call. Okay. Again, avoid printing inside of functions because the print will happen, but the return value is garbage. So return values and then print the result of the function call. We can make default values. We do it all the time. You can define your own functions with default values, or later on in the course, we'll be using other people's functions, and we will be sending in different keyword arguments all the time. And those keyword arguments we send in by the variable name, and with the keyword arguments, you put the name of the argument and then whatever the value is. And just like key value pairs, we can unpack a dictionary of key value pairs with ****. Again, scope is a big deal. We tend not to do too many functions with global variables, but it happens. I encourage us to make functions that are more pure than that. Because if a function is pure, then it's mathematically pure, right? And you're not operating on some global. And then lambdas, to wrap up the recap here, lambdas are one-line functions without a name, right? Sometimes we just need a little one-liner like n+1, or in the example that we covered here, where you're going to see most of your lambdas or use most of your lambdas is if you're using them in a nice little one-liner in conjunction with something like sorted, min, or max. Okay. So folks, functions are a big deal, right up there with loops and conditionals and data types. My advice on practicing functions is to practice the heck out of writing functions. Just practice, practice, practice. We have tons of exercises here that we'll have you get into. My advice on getting even better with functions and writing functions and solving problems is make a fresh copy of those 101 exercises and drill those sometime between now and the assessment to practice for the assessment. And then just in general, repetition and practice makes permanent, right? So my suggestion would be to grab a fresh copy of those 101 and add that to your list of practice. All right, I'm going to stop recording now, and that is functions, folks.